Okay, video lesson 1.8, coordinate geometry. You spent an entire year in geometry learning about geometry. You learned a little bit of it even in 8th grade, or for most of you, 7th grade, and you reviewed a lot of this last year. So I'm not going to reteach you everything. I'm really just going to kind of hit the more complicated points in this lesson. First off, you should know distance and midpoint formula. You should have these formulas memorized. If you don't, you need to memorize them. This is something your college professors will totally expect you to know. Remember that distance formula really is just like Pythagorean theorem. You're taking the difference between the two x's and squaring it. That's like a squared. Difference between the two y's, that's like b squared. And then you're square rooting to find c, the hypotenuse, which is the distance between the 2 points. Midpoint formula also should make sense. You're averaging the two x's to get the x that's in the middle. You're averaging the two y's by adding them up, dividing by 2 to get the y that's in the middle. All right, so let's do a problem that you may not have seen before, but you have the knowledge to do it even before this lesson. All right, so it says find a point on the x-axis that is equidistant from the points 2, 2, and 3, -1. Picture always kind of makes things make a little bit more sense. So I'm gonna graph 2, 2, and then 3, -1. And we're looking for a point on the x-axis. Now, I don't know where it is exactly. It's not going to be a whole number either. Okay? Or it doesn't have to be, I guess I should say. It doesn't have to be a whole number. But let's say it's right here, because the way I've drawn the picture, it does seem like it should be about right there. It's not. I'll just tell you this is not the best picture, but it'll do for what we need. I'm looking for where these two segments are equal. Okay, so first off, they're giving us a point on the x-axis. So our point is going to be some value of x and then 0. The y value of our point is going to be 0, which is extremely useful. If I didn't know that, I really wouldn't even have enough information. So I'm going to set up the distance between 2, 2 and my point x 0, and then also my 3, -1 point and my point x 0. And if they're equidistant, then those two distances should equal each other. Okay, so on the left-hand side, let's do with the point 2, 2. So I would have square root of, and let me write this one here just to make it even more obvious. So I would have x - 2 squared plus, then this would be 0 - 2 squared. And you can simplify this side down, or you could go ahead and write the other one and then start the simplification. So over here, you could do 3 minus x. Just to keep things simple, I'm going to go ahead and do x - 3 squared, and then 0 minus -1, which would be 0 plus 1 squared. And now let's simplify. You could try to simplify the sides down individually, or you could take the easy way out, which is to square both sides. Okay, so then I have x - 2 squared, and then -2 squared would be 4. Over here I have x - 3 squared, and then 1 squared is 1. Okay, so now what we need to do is we need to simplify it down even further, and it looks like I didn't really leave myself quite enough room. So I'm going to FOIL this out. Now if you need to, so that you don't make a mistake, do that. So x times x would be x squared. Outside and inside would be -2x, so that makes -4x. -2 times -2 is +4, and I have another +4. Okay, over here I have something very similar. I'm not going to go through these steps in detail. You should know how to do this stuff so well. All right, now when you start simplifying, probably the most obvious one would be to do is to make that 8, that 10. But whether you try to get everything on the left, try to get everything on the right, when I subtract x squared, it's going to cancel on both sides. All right, so I really don't even have a quadratic anymore. So I just have a linear. So I'm going to add 6x. So I'm going to add 6x to both sides. So that gives me 2x. And I'm going to subtract this 8. So I have just the integers on the other side, which is 2. So then x equals 1. So it did turn out to be a whole number. So you can see my picture was way off. It really should have been over here at 1, 0. Now you could easily check this by actually finding the distances as well, if you wanted to go back and do that. Okay, now let's talk about x and y intercepts. You know how to do x and y intercepts of lots of functions, and we'll review it, but remember that there's just one basic thing. If you think about x-axis and y-axis, an x-intercept, no matter where it is, just like what I just said, an x-intercept is always in the form x comma 0, meaning its y value is equal to 0. Just like that, a y-intercept, no matter what type of function you're dealing with, will always be 0 comma y, meaning that the x value is 0. So if I give you a strange function, well, this is actually not a function, but if I give you a strange equation, like this in example 2, and I ask you for the x and y intercepts, you should be able to do it even if you don't remember anything about this. Hopefully, at least some of you out there did look at this and remember that this is an ellipse. I know it's an ellipse because I have an x squared and a y squared, and there's two different numbers underneath them. So it's not quite circular. It's being stretched more horizontally than it is vertically. Okay, so even if you didn't remember that, that would be okay. You could still do the x and y intercept. Okay, so let's start with the x-intercept. So for the x-intercept, you would plug 0 in for y. So x squared over 9 stays the same, but this whole term here, you really wouldn't even need to write because it's going to be equal to 0. So really I'm just thinking x squared over 9 equals 1. Well, that's the same as x squared equals 9 if I multiplied both sides by 9. And then if you're thinking 3, you're half right. It's plus minus 3. Both positive and negative, 3 squared equals 9. So your two x-intercepts are 3, 0 and negative 3, 0. Not intervals, but actual points. Okay, now let's do the y-intercept. There's probably going to be 2 of those. So this is where we set x equal to 0. Again, we didn't really have to write that first thing because it's going to cancel. And then I have x squared over 4 equals 1. So this is the same as y squared equals 4. So then if I square rooted both sides, I would get plus minus 2. And one of my y-intercepts is 0, 2, and the other is 0, negative 2. Just based off this alone, you could come up with a pretty good graph. Then you could go into center and all that. And we'll review conics kind of as they come up. We're not going to do all of everything with conics right now. Okay, so probably thinking we skipped circle. We didn't. I'm going to go over this a little bit more detail because this is used quite a bit in calculus. So we're going to make sure that you guys understand the circle. So we know that the center is HK, the radius is R. Remember that it's minus and minus. It's just like thinking about transformations. When it's on the inside of the parentheses, it's opposite of what you think. So this is a shift to the right, H, and this is a shift to up, K. That's why there's minuses, and that's why it has to be the way that it is. All right, so it says find the equation of a circle with radius of 3 and center of 2, 5. Well, they've given us all the information. They've practically given us the answer. So x minus, here h is 2, and then squared, and then k is 5, so y minus 5 squared. And then what a lot of people forget to do is square the radius. It has to be squared in order to correctly represent the information given. And so that's the circle. Don't multiply it out. Don't do anything else. That's it. All right, these get a little bit harder when I give you the equation and it's not in this nice, neat form, but it's all multiplied out here. So this is why you don't really want to multiply it out, but sometimes it's given to you this way. This is when we're going to review completing the square. We haven't yet done this. We didn't ever have a time where we needed to do this in the trig semester. So first thing, let's group all the x's. x squared plus 2x. Let's leave some space. And then let's have y squared minus 6y. Let's leave some space. And let's actually subtract the 7 over, so that's negative 7. It won't stay a negative number. We're going to make some changes so that I will get a good r squared over there, because I would not want a final equation of a circle to have a negative number over here. All right, now if there had been leading coefficients in front of x squared or y squared, we would either need to factor those out or divide them out. We don't have that here, which is nice. All right, but remember that there's a nice little technique for completing the square. So you take this number that's in front of x, I'm going to go over here, you half it, or divide by 2, that gives me 1. I do this thing called half it, box it, square it, which your teachers might have used last year. And so the reason I do it this way is because you want to take this number, you want to divide it by 2, and you want to square it. Whoops. Okay. This number right here, it's kind of confusing on this particular one because they're the same number, but that number is what completes the square, what makes this binomial into a trinomial that will factor into x plus something squared. That's why it's called completing the square. The box then tells you what to put right here, although it should be kind of obvious that x squared plus 2x plus 1 is x plus 1 squared. All right, now I didn't balance it though. Since I just put a plus 1 here, I've got to do that to the other side. And now I'm ready to do the same thing over here with my y group. So then I have negative 6 divided by 2. That's negative 3. I'm going to box that and square it, and I get 9. Now 9 is what completes the square, so I write it over here as well. Okay, I'll deal with the right-hand side in a minute. But y squared minus 6y plus 9 is the same thing as y minus 3 squared. And if you box this, then it's really easy to know what that number is supposed to be, but you could also have factored. All right, negative 7 plus 1 plus 9, that gives you 3. And so now I have it in the form that I want. My center is going to be negative 1, positive 3. You take the opposite sign on both of them. All right, and then the radius is not 3, it's actually square root of 3. Remember that in the formula this was r squared, so r is actually just 3. R squared is 3, so r is square root of 3. And these two things are what they were asking you to find. Okay, the last thing we're going to talk about in this has to do with symmetry. All right, now in geometry, you dealt a lot with symmetry. You did a lot of rules and all this kind of stuff. So we're going to talk about the three most basic types of symmetry. Let's think about a point that is reflected across the x-axis. So let's say we start with the point xy. If I reflect that point across the x-axis, let me draw a little xy axis up here, xy grid. If I reflect it across the xy axis, the x value will stay the same, but the y value will become negative. Okay, so if I have a graph that's symmetrical with respect to the x-axis, then y's being positive or negative, they'll yield all the same points. And now I'll do an example with this, so it may not be exactly clear, but if you can follow that a point reflected across the x-axis looks like this, then you're in good shape. All right, so let's think about a point reflected across the y-axis. So in this case, if you start with just your standard point, xy, then your x will become negative, or not necessarily become negative, but if it is negative, become positive. You'll negate it, in other words, positive to negative, negative to positive, and the y value will stay the exact same. Okay, now if something is reflected, or really this is not so much, we say symmetrical with respect to the origin, but what this really means is 180-degree rotation. Okay, which is talking about multiple reflections, but 180-degree rotation would be the best. So think, if we had something in the first quadrant, we had 180-degree rotation, which should be halfway around, they would both become negative. Okay, and here, same thing. It would negate. So if you had an xy point, it would cause it to become negative x, negative y. Now, all this to say is this was going to help us then take an equation, okay, because obviously you can look at a graph and tell me if it's symmetrical across the x-axis, y-axis, or if you could do a 180-degree rotation. You did all that in geometry. But what I want you to be able to do is do this with an equation. So what we're going to do is have a test. If you can replace x with negative x, simplify it down, and it's the same equation, you have respect to the x-axis. If you replace y with negative y, if you replace x with negative x, that would give you a symmetry with respect to the y-axis. Okay, if you can replace y with negative y, then you would have symmetry with respect to the x-axis. If you do both in the same turn, okay, from the original equation, replace x with negative x and y with negative y, and it simplifies down to an equivalent equation, okay, or expression, then the graph has symmetry with respect to the origin, which means there's a 180-degree rotation. So what we're doing is we're really focusing on the equation, not so much the graph. All right, so here we have a cubic, and a cubic is interesting. Some of these that you're going to have to practice with are going to be obvious to you, and some of them are not. I doubt this is really obvious to many of you. So let's test the x-axis. Now remember, to test the x-axis, we're going to replace y with negative y. So if I put a negative y in place of y, what I want to ask you, is there any way I can simplify and this equation will be the exact same as the equation I started with? No, there's no way to do that. Now, if this y had been squared for some reason, that would give me a really weird not function, but if that y had been squared, well, then that negative then would have been irrelevant, and that would have been an unchanged graph or equivalent graph or equation. But this is not the same. Okay, so there is no symmetry with respect to the x-axis. All right, let's test the y-axis. This is where we replace x with negative x. So where x is, and I'm going to put this in parentheses because I'm replacing it exactly where it is. Let's simplify this and see if it, because there's potential here for that to happen. All right, negative x cubed would be negative x cubed this way, meaning negative, then times x cubed. This would be plus 9x, and you may be thinking, nope, it's not the same. Well, let's factor out a negative 1 because I still have hope. Although it didn't work because I still have this negative 1 I have to deal with. So it is, again, it's not the same. So there is no symmetry with respect to the y-axis as well. There are times, though, when you might factor that out and it doesn't matter. And it's hard for me to right now in one example tell you everything to expect. So you're going to have to work it out, and you can definitely ask me questions. But let's test the origin. So if you're thinking logically, probably this is going to work. So let's replace both the y with a negative y and the x with a negative x. Okay, so this becomes negative y, this becomes negative x squared, this becomes plus 9x. It's like a combination of the two. So I have negative y, I'm going to factor out that negative 1 again, and I'm trying to make this equation look like the original. Now how, I'm going to go ahead and tell you this will work. How will it work? You can either multiply or divide both sides by a negative 1. Doesn't matter whichever way you think of it. You will get the exact same equation. And if you can get this, which is the same, that tells you that this graph has symmetry, and you'd write it out like this. This graph has symmetry, you can abbreviate, with respect to, you can abbreviate here as well, the origin, meaning there's a 180-degree rotational symmetry. Okay, not all cubics necessary. Well, not all I don't want you to try to memorize any rules here. I want you to use these tests, and I'll leave it at that. Bring your questions to class.